In this example, we have a current carrying wire sitting in a magnetic field. When the current is turned on, we see that these wires compress by 1 centimeter, so it squeezes in and the wire gets pulled into the left. The question is, how big is the current? So what's happening in this picture is that there are forces acting on the wire. There's going to be magnetic force and spring forces. So what we can do here, and let's assume that we're going to neglect gravity. Let's assume that the mass of the wire is small enough so that it'll be insignificant compared to the magnetic and spring forces. Let's draw a free body diagram. Let's put in what we know about the forces, and let's see if we can figure out what the current is. So I'll redraw the wire right here. We ask what forces act on our wire. Well, our springs are compressed, so the springs have gone this way, which means it's pulling the bar to the left. So there's a spring force. 2 springs, so we have 2 spring forces. If it's pulled to the left, the other force must be to the right. Let's just check that with our right hand rule. Our thumb goes with our current, finger is with magnetic field, and index finger is magnetic force. So yes, that's pushing to the right. So there's our magnetic force. It says that the springs are compressed by 1 centimeter, so it doesn't say they keep moving, they are compressed. So that makes this a static problem, which tells us that the sum of the forces is going to be 0. So let's write down our Newton's second law statement. The sum of the forces in the x direction is mass times acceleration in the x. The forces we have are a spring force to the left, so it's negative, another spring force to the left, so it's negative, plus a magnetic force, which points to the right. The acceleration is 0 because the thing is not moving. Okay, what's the magnitude of each of our forces? Spring force, hopefully you remember, spring force is spring constant times the amount of compression. So the magnitude of each spring force is equal to k times x. So that's going to be 10 newtons per meter times 1 centimeter equals 0.1 newtons. Our magnetic force FB is equal to I times L times B times the sine of the angle between L and B, which is 90 degrees. So our current I is something we'd like to find. L is 20 centimeters, 0.2 meters. B is the magnetic field, 0.5 teslas. So we've got I, 0.2 times 0.5 is 0.1. 0.1 teslas times meters. Okay, we can put these things in our equation now. So we have minus 0.1 newtons minus 0.1 newtons plus I times 0.1 teslas times meters equals 0. Can solve for our I is going to be 0.1 newtons plus 0.1 newtons divided by 0.1 teslas times meters gives us 2.0 amps. So that's the current in the wire that causes those springs to compress by 1 centimeter.